What we're looking at today is using Cramer's rule to solve systems of equations. And Cramer's rule is utilizing determinants. What we'll do for Cramer's rule is we'll take a system of equation and write several determinants. The first one is going to be called determinant of C. And C is just taking the coefficients, the numbers in front of the variables, for our matrix, or in front of the variables, and turn it into a matrix. And we're going to call that matrix C. So we turn that into matrix C, and we're going to take the determinant of it, and it goes on bottom. Now for the variables x and y, what we're going to do is do the same thing, but for x, we're going to replace the values that are in the x spots with what it's equal to. So here, because this is equal to m and n, we put it in places of the x. For when we're solving for y, we're putting in place of the y values and taking the determinant. Now this is going to make a little more sense when we actually look at it here. So we have this equation, and we're going to want to solve for x. So we have the determinant of the top and determinant of the bottom. Now the determinant of the bottom is just going to be the coefficients in front of the variables. So for x, well, we have 5 and 3. For y, we have -6 and 4. Because we're going to want them 5 and 3, 6 and 4. We want them lined up. X's are going to go first, y is going to go second. Now in the numerator, since we're solving for x, we're not going to put 5 and 3 because those are the x values. We're going to replace it with what they're equal to. So the first value would be 15 and the bottom would be -29 because that's what those two equations are equal to, and we're solving for the value of x. Now the y values would stay the exact same, so we have -6 and 4. Any questions on how we set this up for x? Let's look at how we're going to set it up for y. Now the determinant on bottom is going to be the exact same as x, so we're going to have 5 and 3, -6 and 4. Now the numerator is going to be different, because the first two values going down are going to be what? 3. The next two are going to be a -29. But since we're solving for y, we're putting what the equations are equal to in the y value spots. Okay. Questions on how we set this up for x or y? So what we need to do next is we just need to take the determinants of the top and bottom of both of these here and simplify, and we have the values of x and y. So if we look at this first one here for x, because this is a second order determinant, we have a 2 by 2, we are doing the cross method. So we're going to take 15 times 4 and subtract from it -6 times -29. On bottom, we're going to have 5 times 4 minus -6 times 3. Now at this point here, we could type this whole thing into the calculator, because the calculator would do this for us, and it would tell us exactly what the answer is. It's 38 over what? 234? Okay. It would be a little big, because I do agree with 38, because 15 times 4 would be 60 minus 4 is what? 114. Yes, I would agree with that. -114 over 38. Well, actually, this is to -3. Questions on this here? Because to get 38, we just took 5 times 4 and subtracted from it -6 times 3. We would get this here, because 5 times 4 is 20 minus -18, which would just be plus, and we get 38. So are we good with this first part here? Yes? Now we can do the same thing for y. The values of y. Now in the numerator for y, we would have 5 times -29 minus 3 times 15, yes? And this is going to be over what? Well, exactly, Colton, because we could say 5 times 4 minus 6 times -6 times 3, yes?
My question.
Yes.
On the x, we did -6 and -5. Why did we do 3?
Where at?
On x, we did -6 and then -29 at the top part.
Yep.
And this will be 3 and then.
Right, because here we replace the x values with what it's equal to. Over here we replace the y values. So when we do the cross here, it's this and this. So over here we're doing these two and.
So you're confused by the fact that you put -6 and 29.
Okay, yeah. Yeah, the order of the multiplication doesn't matter. Any other questions on this here? Why can we write just 38 instead of doing the multiplication out? Yeah, because the denominators of these, the determinants, are the exact same, yes? But we already found one of them to be 38, so the other one has to be 38 as well. So now we just need to simplify the numerator. So we do 5 times 29, which should be -145 minus 45. This is going to be over 38. -190 over 38, which is, so the solution for this is -3, -5. Now, is this the most effective way to solve two variable systems? No. I mean, doing elimination would have been easier than doing this here. Or if we just typed it into a matrix and did our row reduced epsilon form, our RREF, which we covered in August, would have been a lot faster than this here. Let's look at one more. We can do 4A or 4B. Which one do y'all want to look at? Okay. Now this time we're going to do this in the calculator, but we'll set it up first for x and y. So when we're solving for x, the numerator, we're going to replace the x values, the numbers for x, with what the equation's equal to. So here we'll have 37 and -41. The y value is -7. The denominator is just going to be the coefficients. So we have 7, 3, -5, and -7. For y, the denominator is going to be the exact same as was for x. But the numerator, this time we will have the values of x, but the values of y will be what the equation is equal to. Any questions on this here so far? So looking at these two here, the equation for x and y, how many different matrices do I have? 3. Because we do have a total of 4, but the denominators in both are the exact same, yes? So if I want to use the graphing calculator, I'm going to need to define 3 matrices. We don't need to do 4 because the bottoms are the same. So we can set A as 37, 3, negative 41, negative 7. We can set B as 7, 37, negative 5, negative 41. And C, we can set up as 7, 3, negative 5, negative 7. Clear that out. I'll clear the key history out too. So what we can do first is we need to input the matrix. So we can go second matrix over to edit, and we'll edit matrix A. This here is a 2 by 2, and we'll input the first matrix. Now our first matrix would be 37, 3, negative 41, and negative 7. Now to input the second one, we can just go second matrix, edit, go down to, well, if I can hit the right key, B, which is going to be a 2 by 2, which will be 7, 37, negative 5, negative 41. Then we go second matrix, edit, C, which is still a 2 by 2, 7, 3, negative 5, negative 7. And I have a feeling you all had these typed out a while ago. Yes? Y'all are getting a lot faster at typing these in. Well, now we can go second quit because we got to get back to the main screen. Now there's 2 ways we can go from here. The first one is we can just take the determinants of A, B, and C and get what the numbers are and divide them by hand or do the division in the calculator. Or we can do it all at once. Because what we can do is alpha y equals enter. So for x, we want the determinant of which matrix on top? A. So we can go second matrix over to math and hit enter for the determinant. Now we need to recall matrix A, which is second matrix, and we can just hit enter for A. Over, well, we want the determinant again. Now which matrix do we want on bottom? C. So we can go second matrix and C. And once we get this typed in, we hit, and it tells us that the value of x is 4. Value of x is 4. So, any questions on how we found the value of x? Now we need to find the value of y, yes? The overall setup of what we're doing, these here are the determinants. Now, the overall setup of actually how this works is a mystery to me. I haven't actually taken the time to delve into it, and I haven't had a class that actually delved in beyond this is the formula. But it is something I'll probably look into here. But according to Cramer, this does work. And it actually ends up working out quite nicely. Well, nicely is a relative term there. Because we need to find the other determinant. I think most of y'all have already typed it in, yes? And I have a feeling y'all went alpha y equals enter. I would go up twice and hit enter and recall that back down, because the only thing we're changing is what? The only thing we're really changing is A to B. And what I can do is come over here and cursor over the top of where A is at, go second matrix B, and get 3. So a lot of the times when I'm doing stuff in the calculator and I know that I'm only changing one thing, I'll go highlight it, bring it back down, make that one change until I have to calculate again. Well, and that tells us that the solution for this here is the 0.43. And that's it. On this here. We ready for what's next? Three by threes. Now, the process that we're going to do to solve these 3 by 3s using Cramer's rule is essentially the exact same thing as what we just did. Because if you look at this here, let me get a highlighter. Oh, okay, apparently. Because the values for x in this 3 variable are mn and p, yes? Where do they show up? They are what the equation is equal to. When we solve for y, well, it is mn and p. For z, it's mn and p. So is this really changing what we did for the 3 by 3, what we did for the 2 by 2, or 2 by 2 for the 3 by 3? No, it's the exact same setup. We just now have 3 variables instead of 2. And our determinants are for a 3 by 3, not a 2 by 2. So, solve the following system using Cramer's rule. Well, the numerator, we're going to take the 3 values for x and replace them with what the equations are equal to. That would be negative 14, 47, and 15. Then we'll have 5, negative 2, negative 6, negative 6, 7, and negative 8. On bottom, we'll have 4, 3, and 5, negative 6, negative 6, 7, negative 8. So really, we just replace what x was, x's values with, what the equation is equal to. Well, y, we'll do the same thing. 4, 3, 7, negative 14, 47, and 15, negative 6, 7, negative 8. 4, 3, 7, 5, negative 2, negative 6, negative 6, 7, z, 4, 3, 7, 5, negative 2, negative 6, negative 14, 47, and 15. 4, 3, 7, 5, negative 2, negative 6, negative 6, negative 7, negative 8. This time we're going to have 4. So we can set A as negative 14, 47, 15, 5, negative 2, negative 6, negative 6, 7, negative 8. And then 4, 3, 7, 14, 7, 15, negative 6, 7, negative 8. 7. Wrong. There it is. So again, since we have 4 different ones, we'll want to plug in 4 different matrices. So we can go second matrix, over to edit and enter for matrix A. Matrix A is a 3 by 3. So negative 14, 5, negative 6, 47, I think it's negative 2, 7, 15, negative 6, negative 8 would be the first one. Second matrix B, 3 by 3, 4, negative 40, negative 6, 3, 47, 7, 7, 15, negative 8 would give us the second one. We go second matrix, edit, matrix CC, which is a 3 by 3. And this here would be 4, enter, 5, enter, negative 14, 3, enter, 2, enter, 47, negative 6, and lastly 15. And we go second matrix over to matrix D, which would be this right here, yes? And once we get all of those inputted in, we're going to find the determinant of top over bottom, yes? Some of you might have gone on and done alpha y equals enter to get the fraction. I'm just going to recall this here, because I can replace matrix A or B with matrix A over. We wouldn't want matrix CC, we want matrix CD. So the first value for this is 5. Okay. Replace A with B. And find out the second value is negative 2. And does anybody have what the third one is? 4. Second matrix C, 4. So 5, negative 2, 4. Questions on this here? And that's it. That's all we're covering today. Any questions on anything we cover here? So the homework, again, is a worksheet. And all the homeworks this time are going to be worksheets, because that way y'all don't have to carry around a textbook for these here. I think that'd be 4. Here's pass all for Tristan. I had a feeling. And y'all can go on and get started on those there.